Hi, and welcome to our first slide deck, hopefully of many, where I will try to give you a quick and thorough explanation of some of the skills that are needed to be successful on the Accelerated Math Test-In, which is again on May 7th. I would encourage you to have the slide deck that I sent to you as a PDF open in maybe a split screen, so that you can take some additional notes as you're working through these problems with my guidance. And I would also encourage you to pause the slide deck show as I'm working through to work on the problems and make some notes and then continue with it. So the goal of the following slides is to introduce you to the rule of exponents and then scientific notation with these rules of exponents for division and multiplication. We're going to begin with exponents, and we will be focusing on the rule of zero, the product rule, the power rule, the quotient rule, and the negative rule. So let's get started. The rule of zero, basic rule of zero, the main point is that everything, and I certainly do mean everything, that is raised to the power of zero is always one. It is always one. There's a lot of discussion that goes on about what happens when zero is raised to the power of zero, but we are not going to discuss that. At some point later in your mathematical future, you will meet a very smart college professor and they will give you all that information. And when they do, please make sure you come back and tell me, because I am still debating what zero to the power of zero is. So moving forward, simply put, zero is something you want to eliminate first when you're looking at multiple math problems and multiple exponential problems. Always keep that in mind, that prior to diving into any problem, you should seriously think about pausing, taking a little walk through, a little journey through your problem, and identifying all of the little parts that you have within the problem. The goal always being to eliminate part of the problem, do less math. Okay, so here we go. I would encourage you to pause this slide deck and work through all of the problems in the PDF that hopefully you do have open next to you, and then come back and check. So I'm going to begin hoping that you have tried all of the problems and are ready to go through your fabulous answers. So for our very first problem of 3 to the power of 0, our base right here is a 3 and our exponent is a 0. So like I said before in the explanation, anything, and I do mean anything, raised to the power of 0 is 1. So 3 to the power of 0 is the value of 1. 5 to the power of 0 is the value of 1. 10 to the power of 0 is the value of 1. Isn't this lovely and easy? X to the power of 0, again, it's 1 because we talked about anything being the power to the power of 0 being 1. So now we get to our first kind of multiple problem. In exponents, you need to really start to think about how you can separate things because we put multiple things in one problem. Yay! What we have here, 3 times x to the power of 0. So what I encourage my students to do is kind of put a squiggly line here so that you know that you actually have two problems. So this problem is just the number 3, and then this problem is x to the power of 0, and you're multiplying those two things together. So 3 doesn't change, it's just good old-fashioned 3 as we bring that down. And then x to the power of 0, well, we just did that right here. And we know from prior knowledge that x to the power of 0 is 1. So when we simplify this problem, we have 3 times 1, or we have an answer of 3. So that's a little bit of a challenging thought, so maybe pause, go through it again. Moving forward, 7 to the power of 0 times x. So we're going to put a little squiggly line here, and we're going to separate our problem to be 7 to the power of 0, and then to be x. Well, we know that anything to the power of 0 is 1, and then the x is just x. So we have 1 times x, which is going to give us x. And that is the power of 0. Moving on to the next rule, we're going to talk about the product rule. What is the product rule? Well, the product is the answer to a multiplication problem. So we are going to be doing multiplication of exponents. When you multiply, there's two things you need to think about. The first thing is you will multiply your whole numbers together to get a solution. And then the second thing is that you're going to add exponents of the same base. What do I mean by same base? Well, x to the power of 3 and x to the power of 4, those both have a base of x. If I had x to the power of 3 and then y to the power of 4, these are not the same. I'm going to erase that because that is super confusing, Mrs. Brewer. These are not the same because x to the power of 3 right here has a base of x, while y to the power of 3 right here has a base of y. You cannot combine them. So moving into our math, let's go to the next page. All right, again, it is very important to survey our problem before we begin. So like I just said, the base in this problem of x to the power of 5 times x to the power of 6 is x. It's a multiplication problem. You are multiplying two like bases. The exponents are 5 and 6. Moving on to the next example that I have, we're going to do these problems on the next page, so don't worry. In this example, 3x to the power of 4 times 2x to the power of 5. Your bases, again, are x's, so you're going to be able to combine those. But you are also doing a multiplication problem of 3 times 2. So you have exponents of 4 and 5, bases of x, and then actual whole numbers of 3 and 2. So there's kind of a lot going on. So here is our example page, our simplify page. I would encourage you to give it a try and come back. So pause the video, do some problems that hopefully you have your slide deck side by side, and then come back and check in and see how you've done. So hoping that you've done that, let's move forward with our explanation. Our very first problem is x to the power of 5 times x to the power of 6. This is a multiplication in between those two problems. You can see that we have like bases of x for each one of these. So what we're doing is we are taking the exponents and we are adding them together. The words we use are, with like bases, we keep the base and we add the exponents, which means we have a solution of x to the power of 11. That is our answer, x to the power of 11. Let's move on over here. We'll do this one next. So again, this is the same problem as on the slide before this one. We have two problems here. We have 3 times 2. We have 3 times 2. We're going to separate those. Those aren't exponents. They are just 3 times 2. And then we have this problem. We have x to the power of 4 times x to the power of 5. So we're going to do this problem right here. 3 times 2 is 6. And then we're going to do this problem. So what is this problem? It is similar to this one we just completed. So the rule says you keep the base. If it's alike, which it is, it's x. And then you add the exponents, 4 plus 5. So now we have 6, and then we have x to the power of 9. That is our simplified solution, 6x to the power of 9. All right, let's move down. So sometimes for a problem like this, it is literally the same as the problem over here, but we're rewriting it, trying to make it a little confusing for you, because why would we not? Ha ha ha. So what you're going to do is you're going to look at all the parts. We actually have 3 parts in this problem. I'm going to highlight all of them. So the first part we have is just a number. The second part we have is the variable x and the exponent. And then the third part we have is the variable y. We have 3 parts to this. So I'm going to try to keep them straight and do them with the colors that I just highlighted. So I'm going to do this math over here. All right, so the first thing that we have is just the whole number 2. That's just going to hang out, and we'll combine everything together when we're done. The next thing we have is x to the power of 7 times x. Now, it's really important that we understand what is here. when there is no exponent, it is exponent 1. So keep that in the back of your brain. It is exponent 1. Moving on to our green, we have our last part of our problem, which is a y. All right, so we're going to keep our whole number 2. Nothing is happening to that. We're going to work on our bases of x. We have x, and we have 7 plus 1. And then lastly, but certainly not least, we have y. So continuing to just simplify this, we have 2, and then we have x to the power of 8, and we have y. And we're going to just write the whole thing nice and pretty all together. We have 2x to the power of 8 and y. And that is your solution to that problem. You do not need to show all of these steps. I'm just kind of breaking it down for you and trying to make it as straightforward as possible to understand. All right, so let's move on to our next problem. I'm going to put a little barrier line up here so that everybody can kind of understand that we're not doing the same problem. All right, so moving on. Let's do some highlighting so that we can keep track of things. We will highlight our x variables in blue, and then we will highlight our y variables in red, and I will simplify it according to that. So the first thing that we have is our x to the power of 3 times x, and remember, what's up here, everybody? A 1. And then to that, we are going to have y, and again, what's up here? It's a 1 times y to the power of 6. All right, so moving on, we have x to the power of 3 plus 1, and then we have y to the power of 1 plus 6. And keep eating it going. We have x to the power of 4, and then we have y to the power of 7. And we'll write that down as a solid answer, all combined together, no more parentheses. We have x to the power of 4, y to the power of 7. How'd you do? I hope you did okay. Go back, review, and of course, we will be meeting on Monday during my time, so if you have actual specific questions, we can go through them. All right, moving right along. The next rule is the power rule. The power rule is when an exponent is raised to an exponent. So our example here is parentheses 2x to the power of 2 and parentheses raised to the power of 3. This is an exponent. So this is a power rule. 3 is being distributed to all of the individual problems that are inside of the parentheses. So we have a distributing rule. So again, one more time, I think maybe for this very first problem, number 1, why don't you watch it and then pause the video and see if you can simplify number 2 and number 3. Or you can go right ahead and give it a try. Totally up to you. So as I said in the last slide, this is a distributing property. So we are taking 3 and we are distributing it to that, and then we are taking 3 and distributing it to that. So we're going to rewrite the problem with the simplification in here. So we have 2 raised to the power of 3 times x to the power of 2 raised to the power of 3. So that's what we're going to be doing. Let's do this very first one first. We have 2 to the power of 3. I'm going to keep going there. Now, if you were in my class, you would be able to leave that as 2 to the power of 3. I am not sure what they are going to look for on the test. So my advice to you would be if it's a power that is 3, 2, or 1, obviously 1 is just 1, I would encourage you to simplify that completely. So 2 to the power of 3 is 2 times 2, which is 4, times 2, which is 8. So we will simplify that to 8. Moving on, there's something I want to mention to you right now. Do you see this parenthesis right here? So when we were first learning about multiplication and order of operations, we said when we have 2 numbers that are separated by parentheses, 2 numbers separated by parentheses, I'm going to give you a little example. If I was to write this like this, you would know, hopefully automatically, that that is a multiplication and that becomes 6. So it's the exact same principle right here. We have 2 times 3. So what we're going to do is we are going to push our base down and we are going to multiply our exponents. 2 times 3 is 6. So our answer is 8x to the power of 6. All right. So pause and give the next 2 a try and then come back and we'll see how you do. All right. So explanation for this next one. We have 2 problems here. Here is our first one and here is our second one. So we're going to have 5 raised to the power of 2 times x to the power of 5 raised to the power of 2. So moving through the first problem, we have 5 squared, which is 25, times, and then again, hoping that you remember that this means multiplication, and you are going to think about this as 5 times 2, which is 10, and that would be x to the power of 10, and then we'll combine both of those, 25, x to the power of 10. Hopefully you did okay on that one, and it's starting to feel a little bit easier. So last but certainly not least, again, we have our 2 problems right here. We're going to distribute our 3 to both of them. I'm going to rewrite them. We have x to the power of 2 to the power of 3 times y. It is to the power of 1. We could put that there, to the power of 3. And I'm going to one more time just show you this. I have this right here. And I have, go this way, 2 times 3, which is 6. And I have 3 times 1, which is 3. All right, so now I'm going to simplify this. I have x to the power of 6, y to the power of 3, and that is my answer. And that, ladies and gentlemen, is the power rule. All right, moving right along, we have the quotient rule. The quotient is the answer to a division problem, so we are going to be dividing. So what happens? The key to the quotient problem, again, the key to the quotient rule is separating the problem. We have done that in all of the examples before. You make individual problems for the numbers and the variable, and then you simplify and combine into one answer. Again, we have been practicing this, so let's see what it looks like. Okay, again, so let's do the first one together, and then you can give the others a try. So in this first example, in this one right here, we only have one problem. We have x to the power of 5 over x to the power of 2. So here is the rule. You take like bases and you take the exponents of the like bases. And what do you do with them? You subtract the numerator and the denominator. You subtract. So the answer here would be 3. So what does that look like as a problem? We would have x to the 5 minus 2, and that would be x to the power of 3. So we are getting rid of our division problem, which is the goal here for the exponents. And sometimes it doesn't always happen, but that's our goal, and that's the answer. All right, let's move on to the next problem. So we have 2 problems right here. We have a number problem, a flat-out division, and then we have an exponent problem. So we are going to write them down. We have 12 over 6. 12 over 6 is a fraction that is just a division problem. 12 divided by 6 is 2. All right, now we're going to multiply that by our exponent problem. We have x to the power of 10 over x to the power of 3. So we have like bases. So this is going to become x to the power of 10 minus 3. So I want you to see, I think I'm going to highlight this because these are the exponents that you're using. Maybe do a little track. Hopefully that helps. Sorry, I didn't do that first. Okay, so what does that become? That becomes 2x to the power of 7. All right, last but certainly not least, again, we have two problems here. And ooh, we have a negative. Let's see what that ends up doing. Okay, we are going to write our first problem down. We have x to the power of 3 over x to the power of 2. And we will write our second problem down times y to the power of 6 over top of y to the power of negative 2. All right, let's do our math. So again, let me highlight so that we can kind of keep track of what we're doing. There we go. So our first problem is going to be x to the power of 3 minus 2. I'm going to complete this problem and then move to the next one. 3 minus 2 is 1, so that is just x. Moving on to our next problem, we have y to the power of 6 minus a minus 2. Please pause and take a look at this. Hopefully you remember the rule. Two negatives make a positive. So this is actually going to become y to the power of 6 plus 2, which is going to become y to the power of 8. And I'm going to come way up top here because I have run out of space. Our answer is x, y to the power of 8. And there you go. All right, moving on. Our last rule of exponents, finally, the rule of negatives. It's actually so much easier than you had feared, at least for your purposes of getting through our test-in process. There's a lot more complicated problems and things that we can do with the rule of negatives, but right now we just need a basic understanding of the rule of negatives. So simply put, you cannot have a negative exponent as your final solution. There is an exception to that, and that's something that we have to note. That is only when we are representing a scientific number. So if it is a scientific notation number, yes, go right ahead, have your negative exponent. But if we are talking about problems like you see on the right-hand side of your screen, that's a no. So as you can see, this very first one, this is scientific notation, and this is okay because this is representing a very small number. This is representing 2, 3. Let's see, I'm going to put a bunch of zeros in here. If I started here and I go 1, 2, and 3, that's where my new decimal is going to live. So I'll write it without the loops. 0.0023 is what this number started out as. So there you go. Now, this right here is just an exponent to the power of negative 3, which you cannot have. All right. Here is the process. So our steps are, you're going to make a fraction with 1 as the numerator. Done. You're going to put the value, and by value I mean the variable, with the exponent in the denominator. So I'm going to put the variable down there. I'm going to change the negative exponent to positive, and I'm going to keep the same value. And that's it. So you're taking this, you're moving it down here and making it positive. And that's all. All right, I would pause this and I would encourage you to give these a try and come back and check. So x to the power of negative 2, you make a fraction with 1 in the top, x in the bottom, move the variable down, and it becomes positive. X to the negative 5, 1, x to the power of positive 5. Now again, you have to take your little journey and walk through this problem number 3 and understand that you have two separate problems. The first problem is just x to the power of 2. And that's it. That's a good, solid exponent. Yay. The next problem is y to the power of negative 4. And of course, you're multiplying those. So this is just going to continue to track down. But this one is going to 1 over y to the power of positive 4. But remember, you are multiplying them. So understanding that this looks like that, when you multiply fractions, you multiply across. And when you do that, x squared times 1 is just x squared. And 1 times y to the 4th is just y to the 4th. So that is your new problem. All right. Hopefully this went okay. We will practice more together on Monday, like I said. Okay, so now we're going to kind of combine our rules. We're going to talk about division and scientific notation. So you're going to follow the rules of division and the rules of quotients, the rule of quotients rather. You're going to divide the numbers. You're going to subtract the exponents. You're going to write the new problem. You're going to check that it's in proper scientific notation and adjust if needed. Ugh, it's exhausting. Let's give it a try. So I have two examples here for you. So what I want you to think about again is what we've done this whole process, is understanding that for this purpose, we have two separate problems. So this is our first problem. It's 12 divided by 3, and I'm going to finish that out. That's 4. And then, of course, I have my scientific notation, and this is a quotient rule. I have a base of 10 to the power of 6. I have a base of 10 to the power of 2. So just like before, I'm going to take these two exponents and I'm going to subtract them. So I have 10 to the power of 6 minus 2, 10 to the power of 4. So I'm just going to rewrite it so it looks pretty. I have 4. Oops, I don't want to use that, right? Because it's not an algebraic number. Let's erase all of this. It's not letting me erase. It is not letting Mrs. Brewer erase. Okay, so we want 4 times 10 to the power of 4. Sorry about that, you guys. Okay. Moving on. Two separate problems. Here's our first problem. 48 divided by 6. That 6 and 8 went on a date, came back as 48. 8 times. And then here is our 10 to the power of 7, all over 10 to the power of negative 3. So again, I'm going to highlight these. This is times 10 to the power of 7 minus a minus 3. Remember, when we have two negatives, what do they become, everyone? And hopefully everyone is yelling, 2 negatives become a positive, yay! So we have 8 times 10 to the power of 7 plus 3, which is 10 to the power of 10. And that is division of scientific notation numbers. All right, last thing, multiplication and scientific notation. So again, same idea. You're going to follow the rules of multiplication and the product rule because we are multiplying. The product rule is multiplication. So we multiply the numbers, which are the big numbers. We add the exponents. We write the new problem. We check that it is in scientific notation proper, and we adjust if needed. Okay, let's do the first problem. We have two problems. We have 7 times 2. We have 2 times 7. And then we have times, I'll make a big times here, base 10 to the power of 2 times base 10 to the power of 4. So let's do this first. We get 14 times, and then we'll do this one. We add our exponents, right? We're going to add these two. So 2 and 4 is 6. So we have 10 to the power of 6. And then what did I say? I said you had to check. Now, remember that our decimal is technically right here. That is not proper scientific notation. We actually have to move that decimal so it's between the 1 and the 4, which means that what we're going to end up doing is adding 1 to this because we have moved the decimal, made a big number smaller. Big, big, big means positive. So this ends up being 1. I do not want that to be in red. I keep doing this, you guys. I'm so sorry, and it's not going to let me erase it, I bet. Nope. I'll just rewrite it in the blue. I want 1.4 times 10 to the power of 7. There we go. Okay, let's do it again. Our first problem is 12 times 5 times. Our second problem is base 10 to the power of 3 times base 10 to the power of 4. Okay, so we're going to do this one first. 12 times 5 is 60. You already know what we're going to have to do. With multiplication, you normally end up having to move the decimal. And then this becomes, we have 3 and 4. So we're going to have 10 to the power of 7. So we know our decimal is here. We're going to move it over that way, which is going to be a plus 1. So we're going to have 6 times 10 to the power of 8. Excellent. The last thing that I have for you here are some links for additional practice. Now, these are links to IXL, and I caution myself and you to send you links for IXL. The problem with IXL is it's a paid service, and the district does not encourage any family to buy this service, so I am asking you to please not do that. If you are lucky enough to have a sibling that is in elementary school, I believe that they all have access to IXL. You might want to be super nice to them and, I don't know, maybe do their dish duty for a couple of days and see if you can get a hold of their password and get in. But that's between you and them. So if you do not have that as an option, I would encourage you to just do what IXL will let you do, which is up to 10 problems a day at no cost. So you can click on the exponent link and it'll bring you to a few practice problems. Remember, some of them could be above the level that we need you to be at. So if that is the case, please skip, ignore, or stop. And the same goes for the scientific notation multiply and the scientific notation divide. So I hope you have enjoyed this video. I hope that it has answered more questions than it has raised. Again, I will be requesting you on Monday for my time, so please try to remember to come into my classroom and please have all of this work done. I am only going to ask for questions, give you one problem from each of the standards, and we are moving forward. So I need you to be ready and prepared, and I'm excited for you to do well on this test. Have a great rest of your weekend.